I will be discussing annuity due over here. So the definition of annuity due was that payments or receipts that occur at the beginning of each period. So you already know that annuity has three characteristics. Number one is that the installment has to be fixed, so it's an equal amount. Two is that it has to be equidistant, and third is that you need to know when the cash flow is going to end. And if the payments or receipts are coming at the beginning of each period, then that is going to be an annuity due. So over here we're going to do the same example that we did for ordinary annuity, but now the cash flow is coming at the beginning of the year. So suppose you save 1000 per year at the beginning of each year for 3 years and on 5% interest. How much will you have at the end of 3 years? Now because it's the beginning of the years, this is the end of the first year. This point represents the end of the first year. The first year starts from 0. So from here the first year starts until here the first year ends. So if it's the beginning of the year, the first payment will come at the beginning of the first year, so at time 0. Similarly, the second payment, this is the end of the second year and it will come at the beginning of the second year. So the payment will come over here. Then the third payment is not going to come at the end of the third year, but instead at the beginning of the third year. So it's going to come over here. So you can see that the cash flow has shifted this way. This is the difference between annuity due and ordinary annuity. I'm going to also draw how we had this for annuity due. So for annuity due, the first for ordinary annuity, the first year payment came over here, the second year payment came at the end of the second year, and the third year payment came at the end of the third year. So this was your ordinary annuity, and the red one is your annuity due. So it has shifted this way. This due to this, your timing of the cash flows is different and your answer will be a bit different. So let's do our new calculations. I'm going to erase all of this. Now over here also you're supposed to find out how much will you have at the end of 3 years. So you need to calculate the future value at the end of the third year. I'm going to open a note, and first we will again use the single cash flow formula to do the calculations, and then I will introduce you with the annuity due formulas. So I'm trying to do this. We have 1000 for 3 years at the beginning of each year, and we need to find out its future value over here. The interest rate in the question is 5%. First I'm going to use the single cash flow formula. I'm going to use this one. I should use more space. Now the present value, the first cash flow is 1000. The interest rate is 5%. And again now the question is what should be the end. So this 1000, now it is coming at the start of the first year, so it will get interest in the first year as well. First year, second year and third year. So now your power is 3 over here. If you remember, in ordinary annuity over here we had power 2 for the first cash flow, because the payment came at the end of the first year. तो पहले साल interest नहीं मिला, लेकिन now the payment is coming at the start of the year. So if you're depositing the money on 1st January, you will get interest from 1st January till 31st December. So you'll get interest even in the first year. and you'll get interest in the second year and also in the third year. So you'll get interest for 3 years in this case. Similarly, you will do it for the second cash flow. Here your power will be 2 because it is at the start of the second year. So it will get interest for 2 years. And similarly, we will have the third year. So the third year, which was getting no interest in your ordinary annuity, is going to, sorry for writing 3 over here, I was supposed to write 1. Will get interest for 1 year because this cash flow is now being deposited at the start of the third year, because it's being deposited at the start of the third year. 1st January you're depositing the amount, it will get interest from 1st January till 31st December. So it has time to earn interest. I'm going to calculate the value for each of the cash flows. So this is giving an answer of 1157.625. So this will become 1157.625. Similarly, your second cash flow, this is 1102.5. 1102.5 plus your third cash flow, 1050. So if you add all of them, you will get the future value at the third year. Similarly, this was a graphical representation. You can add all of them over here. So 1050 plus 1102.5, 1157.625, 3310.125. This is the future value of this cash flow in case of annuity due. So again, this was using the single cash flow formula, so it's going to be very long, and now I'm going to introduce you to the annuity due formulas. The ordinary annuity and the annuity due formulas are actually very similar. If you notice over here, the difference between ordinary annuity and annuity due while doing your calculations was only in N. The PMTs are the same, the interest rate is the same, the difference is only in the N. So once you were calculating it for, it's over here, you were calculating it for ordinary annuity, you had 2 over here, you had 1 over here, and you had 0 over here. So each cash flow is getting an extra year of compounding because in annuity due you're making an advance payment. So every period has one extra compounding period in it. So where there were only 2 years, now there are 3 years. Where there was only 1 year, now there are 2 years. And where there was 0 years, now there is 1 year. So if you look at the formula, that is exactly what the formula is doing for us. Basically, it's the same formula. Till here, the formulas are the same. And because there was one extra period of compounding every time, we're going to multiply this by 1 plus r. This is a multiplication sign, okay? So you're going to multiply this by 1 plus r. Similarly, the present value formula over here is your ordinary annuity formula, and this 1 plus r multiplication makes it your annuity due formula. So till here, your ordinary annuity and annuity due formulas are the same. The only difference is that these are being multiplied by 1 plus r. So if you even have the previous answer, you can just simply multiply that answer by 1 plus r, and your answer will convert into an annuity due answer. So I'll tell you what I mean by that through the example that we were doing. So let me go back to the same example, but now I'm going to use the formula. So I'm going to open a note. we had to find the future value annuity formula. So PMT 1 plus R So this is our formula. I'll put the multiplication sign over here as well. The PMT over here was 1000. The interest rate was 5%. And you had 3 PMTs, right? So your N was 3, 0.05. So first I'm going to solve the bracket. So this is 3.1525. I'm going to multiply both of them. So multiplied by 1000. See, this is what I was saying. This was the answer that you got from your ordinary annuity formula. If you go back to the previous unit, you will see this is the answer you got over here. So if you simply multiply that answer by 1.05 by 1 plus R, your answer will convert to your annuity due answer. So this is 3310.125, and this is the value that we got even in our single cash flow formula. So again, this is the same concept, but this formula will make your life easier. So now we have some practice questions. Suppose you save